Okay, last time we are in the 10.4, the calculus in polar. So what we need to observe is this formula, okay, which is the sector. Okay, so if you have a circle, you have a region. It's called a sector, like a slice of pizza, right? And you can integrate from angle to angle. Okay. Now let me give you some example, and then we can move on. Example. The example is find the area enclosed by one loop of rose curve r equal cosine 2 theta. This is the example. Okay, the question is just finding the area. We have the curve r equal cosine 2 theta. Okay. The question is just finding the one loop. Okay. So we know this is the rose curve, right? So you need to determine how the curve is like. Okay. The curve will be yeah, more or less it's like a rose like that, and it will be 4, okay, 4 leaves or 4 loops, okay, and the question is just asking what is the area only one loop. You can check just loop, this loop. You can choose which one. Okay. Let me mark the area this one. Okay. Now the questions is the theta. Theta 1, theta 2. If I write like this, I want to find the theta. Let's say this is the theta. What will be the theta 2? Yeah, this minus pi over 4 here, right? And this will be pi over 4. Okay. Anyone know how to find? Yes, yes. So the curve is r equal cosine 2 theta, right? Okay. Now, if we look at from polar perspective, the first thing we need to make is the baseline, and you can rotate the angle, right? And when you rotate the angle, it will stop here, okay, at some theta, right? This point is 0, okay? This point is 0. So when theta is pi over 2 here, uh, cos pi over 2 is 0, right? So pi over 2 equal to theta will be pi over 4, okay? Okay, still love you, still confusing. Uh, Here, let me write here. This means the r is 0. So r is cos 2 theta. 2 theta is pi over 2. Okay? Get it from here? So this point, r is 0. How can be? How can r is 0? If the theta is pi over 2, cos pi over 2 is 0. So which means cos 2 theta, the 2 theta will be equal to pi over 2. So theta will be pi over 4. Okay? Okay? If you skip to understand this, all the things in polar you will not be able to calculate. It will be difficult. This is the easy one. Okay. So theta will be pi over 4 here. And same thing in theta 2. This is the mirror of this angle. It's minus pi over 4. And minus in the fourth quadrant, all the cosine will be positive, right? It's just FYI. Okay. So this will be pi over 4, and this will be minus pi over 4. I hope you understand it. Okay. Now we can write down the area equal. The formula is integrations. Let me write the angle, and then half, and then uh, the equations, and then squared. So cosine. Let's just square this, and then d theta. And then, if you think this way, too much calculations, let's just make this 0, right? So we can just calculate half and then multiply by 2. Okay, that's also okay. So area will be 2. Let's say this half and then this 0. And this will be cancelled. Okay. And you still remember how to solve this from calculus 1? Okay. I prefer to just change to double angle, and then it will be easier to integrate. Okay. So you need to change to the cos 4 theta, right? Okay, this is the area. And then I can write down the integrations. You can just integrate all to and because it's sine and it has 0, so the other part will be all 0, correct? And the other one, pi over 4, plug in here, it's directly we get the answer is pi over 8. Okay, one more example. I think one more example. We need one more. Let me move to here. Find area of region that lies inside and outside okay. Now you need to carefully read the sentence. The area you have two curve. Okay. Uh, the first one is the circle, and the second one is the cardioid. Okay. So the questions is find area that lie inside the circle. So you have the circle. So the area should be inside that circle, and then outside the cardioid. So you need to first to draw these two curves. Okay. The first one is just a circle with the radius of 3. Okay. But you need to observe this is the sign. Okay. I think I've shown you before. Uh, if you draw this circle, this is 3 cosine, or this is some constant and a cosine. Okay. If you draw like this one, this will be r sine, right? So if you are maybe the question is maybe minus, then it will be here, the sign, minus sign. And if this is cos, this will be the left one will be the minus cos. Let me erase the folder. So the circle will be here. So let me name this R3 sine theta. So this will be 3, right? The radius. And how about the cardioid? Okay, we have the cardioid here. And what is the maximum value? The sign will be 1 plus 1 is 2. So in the, let's say pi over 2, it will be here, right? Or maybe 1, or maybe around here. Okay. So let me, so it should be around here. Okay. And when sign is 0, R is 1. So maybe this is 1 and this is 1. Okay. Sine 0 is 0, sine pi is 0. So we can create here, create here. So we can at least like this, and then draw. Okay, so that's the our cardio. So where is um, the area that we want to find? It's here. Okay, so inside the circle and outside the cardio. Okay, so this is the area. Okay. So after we draw and find which area we want to solve, the next thing is how to find the area. Now, before we need to find, we need to observe which angle that we need to find, right? We will integrate some parts here, right? But we need to integrate from where to where. But because we already draw the area, we know the point is from here and here, right? The intersection. That's what we want to find first, okay? So 3 sine theta equal 1 plus sine theta. And then we can get this is how. So theta will be, first is pi over 6, okay? And the other one is, let me write completely, pi minus pi over 6, or 5 over 6 pi, okay? So this one is pi over 6, and this one is pi over 6 pi, okay? Okay. But now, how do we write uh, the integrations? We can find within the circle from pi over 6 to 5 over 6, right? this first curve minus the cardioid. Okay, get it? So the area, let me write here. So the area will be this is the circle. Okay, and then minus from the same angle, or actually you can just minus and then it will be the same because it's same integrations, right? But anyway, I'm just writing uh, all of this so that you can see the steps by steps. And then the curve is 1 plus sine theta squared and d theta. Okay, now you can calculate like this, or you can ignore this integration and just minus the same. Anyway, this pi over 6, we can also change just to pi over 2 and multiply by 2 if you want. That's also possible. Okay, so we can change to area. It's twice of it's pi over 6, pi over 2. It's let's say it's half. It's 9 sine squared theta. Let me just write all minus 1 plus 2 sine theta plus sine squared theta. And then d theta. Okay. Now that you can write. Now we can solve 9 and this will be 8. So we will have area is okay, and then oh yeah, 8. And then we can use the double angle formula. So this is sine squared theta. I will write the double angle. Let me just write here since maybe some of you forget how to find. And the final calculation will be you will have my negative 2 sine 2 theta plus 2 cos theta and then plus 3 theta. Okay, so this is I'm integrate directly. And if you plug in all the informations, the pi/2 case, you will get the 3/2 pi, and then pi/6 you will get pi/6 here. This is directly go to pi, right? Okay. Okay. Any questions first? This part is uh, the result of the integration. So some step I'm skipping here, and you get directly here. But to find the sine 2 theta here, you get to from the cos 2 theta, and then you integrate and then find the sine. Okay. Okay. Any questions? By the way, since today I will finish almost of the 10.4, and I will be skipping 10.5 and 6. Okay, I will be skipping that. So we will not have conic sections and conic section in polar. Yeah, we will skip that. But since we are actually finishing chapter 10, so next week will be quiz for chapter 10. Next week. Probably if not Monday, then Wednesday. Okay. I will announce later in the Moodle. Okay. So it will be chapter 10. Okay. Okay, if there's no questions, um, I will continue the chapter 10.4 arc length. So let me write the relations between okay. Let me write this as our basics. So you have the x equal r, and then y equal r sine. And we can also write in terms of functions of theta. Okay. To find length of polar curve r equal f theta from A to B, let's say that's the angle. Remember that from this x equal r cos theta, we need to find the form of the first derivative, right? And then we need to take a product rule from these equations. So you will get dr d theta cos theta minus r sine theta. Okay, and from y equal r sine, we need also to find this form. Okay. Now, in arc length, we need to find this form, right? In the last chapters, we need to find this let's say just this uh, terms, right? So we need to find. Let's just write these two terms. Okay. So let's square all the dx over d theta and dy over d theta. Let's square both of them. The results will be dr d theta squared and then cos squared and then minus 2r dr d theta sine theta cos theta and then plus r squared sine squared. Or let me just write dx over d theta first. But if you are already right, that's okay. You can adjust my writing. Same thing. And the second one, dy over d theta squared. This will be the same. Similar here. And this is minus a plus. And this will be cos squared theta. Okay. Now we need to plus this all terms. Okay. Plus, and this will be okay. Now let's see here. Okay. This is the same same terms we can factorize, right? And we can plus cos squared plus sine squared is 1. So we just write the dr d theta squared. Okay. These two will be cancelled. Okay. And this one will be only r squared, right? Sine squared plus cos squared is 1. Okay. So plus r squared. So this is the arc length. So we can write the arc length as arc length integration and then square root of r squared plus dr d theta squared. So this is the relations between the original parametric convert to polar. This is the terms conversion. Okay, so you have dx. Usually you write dt, right? Dx, dt or d theta, dy over d theta, and then you can convert this xy into r. So dr d theta squared and then r squared. That would be the arc length for polar. Okay, arc length in polar. Okay, any questions? Any questions first? Okay. After this section, we will move to, we haven't uh, discussed the tangents, so we will move to the tangents and then area of surface, and I think that's all for the 10.4. Okay. So this is the arc length. Arc length in polar. Okay, let's move on to the next one. It's the tangents. Let me write all the information or the relation between x and y and then r and theta. And we already derived all the x and y with respect to theta. So let me write one more time. Okay, definitions for the tangents is or just write a tangent. Tangents means dy over dx, right? The gradient. Okay. So dy over dx is dy over d theta over dx over d theta. We can write this as dr over d theta sine theta plus and that's it for the tangent. Some important notes for the tangent will be uh, horizontal tangent and vertical tangent. So horizontal tangent meaning if you have this kind of curve, then this tangent here is horizontal tangent. Meaning the horizontal, the gradient is 0, right? Let me write here d over dx is 0, which means dy over d theta, dy over d theta will be 0, and dx over d theta is not 0 to get the 0. Okay, so we need to write this as dy over d theta need to be 0, but the dx over d theta is not supposed to be 0. Okay, for the horizontal tangent. Now for the vertical tangent, we can say that dy over dx is undefined, right? So dy over dx, dy over d theta is not 0, but dx over d theta is 0. Okay. Okay. Any questions? Okay, let me give you the some example for tangent. Okay, here. Find the slope of tangent line of r 1 plus sine theta. So this is the curve. When theta is pi over 3, and then find points where tangents are horizontal and vertical. Okay, first to find the tangent, you need to just input the formula dy over dx, right? And find the we have the r here, so you know dr over d theta from here, right? And then all the other things just plug into the formula and then use the theta equal pi over 3 and you get the value. Okay. And again, do not force yourself to memorize all the formula in polar. Okay, it's actually more practical if you just deriving it by yourself. Okay, so like for example, let me just write the dy over dx is dy over d theta and dx over d theta. So we need to find dy over d theta from y equal r sine theta, right? And dy over d theta will be dr over d theta and then sine theta and then plus, okay? And then dx over d theta, dr over d theta, and then cos, and then minus r sine, okay? And what you need to do is just using this formula, plug in the r here, plug in the theta, and then calculate the value, and then find dy over dx, okay? So let me use different color. So if you have r equal 1 plus sine, right? And dr over d theta will be cos theta, right? So dy over dx will be dr over d theta and then sine theta and then plus and dx will be dr over d theta cos theta minus, okay, let's simplify. Whatever method you simplify, I think that will be fine as long as it's true. So let me write this cos theta and 1 plus 2 sine. we can write this as you can write this as cos 2 theta, but I think because I want to uh, simplify with sine, let me write this as oh, wrong. This should be, yeah. And you can solve this, you get -1, right? Okay, now the next question is asking the horizontal and the vertical. So horizontal, so we need to find, because we already uh, calculate du over d theta and dx over d theta, we just rewrite the form. Okay. So cos theta 1 plus 2 sine theta should be 0. It can be the cos theta is 0 or 1 plus 2 sine theta is 0, right? So you get theta is pi over 2, 3 over 2 pi, right? And the other one is when sine is negative sign, negative half, right? So theta will be 7 over 6 pi and then 11 over 6 pi. Okay. Do you get it why I'm getting the theta? Or should I explain? No need, right? Okay, what you need just to remember is which one is sign will be positive or negative in the quadrants, and also the cosine, right? I think just sine and cosine is fine. You don't need the tangent. The tangent is just uh, the you derive that from sine and cosine. Okay, so you get the theta, and then the same thing with the vertical. You need to find dx over d theta is 0, right? Then this should be 0. So this I have 1 minus 2 sine theta is 0, which means sine theta is half, positive half. And then sine 1 plus sine theta is 0. Sine theta is negative 1. And from here, we get positive sine is in the first quadrant and then second quadrant, right? So pi over 6 and then a 5 over 6. So pi over 6 and 5 over 6 pi. And then sine negative 1 is 3 over 2 pi. Okay. Now, we have some weird conclusion. Okay, at least we have 3 over 2 here, and we have 3 over 2 here. So the question is it vertical or tangent? We both have this. Okay, so to solve this, we need to at least sketch the graph first and see what it looks like. Okay, so sketching the graph will resulting. So R is 1 plus sine theta. Because we already draw this in the previous problem, then I will just draw and state it the 1, 2. Oh, maybe make it bigger. Yeah, at least like that. And this will be the horizontal. This will be the vertical, vertical, horizontal, horizontal. This will be, this R will be 2. This is pi over 2. This will be pi over 6, right? But pi over 6 is 3 over 2. This will be the same. And this will be half. Okay, that's all the coordinate. And the last coordinate is actually the 3 over 2 pi is here, right? If you see from here, is the R is where is the R, right? Maybe in this point. Okay. Let me give you the notes. Okay, so when theta is equal 3 over 2 pi, this is 3 over 2 pi is here. When theta is 3 over 2 pi, dy over d theta is 0, and dx over d theta is also 0. So you get dy over dx is what? 0 over 0, right? And we know this from calculus 1, the first calculus you get last semester. 0 over 0 situations is indeterminate forms, okay? Indeterminate forms, in which we are not sure what kind of this point is, okay? What kind of tangent will be, right? Because it's indeterminate forms. Then, what shall we do now? We learned that from indeterminate forms, we can approach using limit. Okay, so let's use the limit. So limit as theta approaching 3 over 2 pi. Let's say we can approach from the left or right. The same thing because it's symmetry, right? Let's say we are approaching from the left. Okay, and we are writing dy over dx equal limit as theta approaching 3 over 2 pi from the left, and we can write down all the formula, but let me write maybe around here. So 1 plus 2 sine theta. Let me write completely. Okay, now let's see. 3 over 2 pi, if you plug into just this terms here, it will be 0 over 0. So this is our problem. If you just plug into here and here, these two factor, it's okay, right? It's okay, no problem. But if we plug in here, this will be a problem. So uh, let's plug into here, but do not plug into the right one. But we still need to write the limit, okay? So we can write this as negative 1 over 3, okay? And then limit, and theta approaching 3 over 2 pi from the left, and write down cos theta over 1 plus sine theta. Okay. Now, if we plug in 3 over 2 pi to cosine and to sine, it will be 0 over 0. Okay? It will be 0 over 0. So because 0 over 0, and we are already solve the other part, right? We can use the L'Hopital rule. Okay? We can use L'Hopital rule. So we can use L'Hopital rule. And it will be 3. And then we can derive, still write the limit from the left, and this will be sine negative, and then cosine, right? And if we plug in here, what will happen? Undefined, okay? So we can write this will be undefined. So is it horizontal or vertical? It's undefined. vertical. That's how you get the answer, vertical. Okay. So because dy over dx undefined, then at 0, 3 over 2 pi, there will be vertical tangent. Okay. Okay. So why we are doing all the limit part? Because we find that dy over d theta and dx over d theta is both 0. So we are not sure what is happening there, right? And we cannot also, from the picture, we cannot observe well, right? We cannot justify whether this is horizontal and vertical. We need proof, right? So how to prove that is using the limit, okay? Using the limit. Okay. Any questions? If not, there is actually in your textbook, it's not really mentioning there in these sections, but there is actually a way to find the surface area because we already know that the arc length, right? So can we find the surface area of polar surface? And you can find that actually in the exercise, not in the textbook. So I think in the exercise, like in the 10.4 exercise, near the end of the exercises, you will find some parts telling you the area of surface. So let me just go there, and if we still have time, I will go give you another example, and then we finish the class. But not, if not, then we will just finish up until area of surface. Okay. Area of surface. So if you have the equation R is equal function of theta, and theta is from A to B, the function is continuous, and the theta is in between two. We only observe until pi. You will know why we just observe until pi, and then rotate it. So the curve is rotated about the polar axis. So if this happened, what is the formula for the area of surface or surface area? Okay. So first, you need to see the restrictions, okay, the limitations of all the the terms here. Okay, you have the curve, you have the angle, bowl angle, and then the important point is this one. Okay, so the restrictions is from 0 to pi. Okay, why? If this is 2 pi or more than pi, or maybe 3 over 2 pi, you will not be able to find the surface of area. Do you know why? Okay, like the other case in parametric, it's also stated that the curve needs to traverse or move at least once. So if the graph turns backwards, when you rotate, it will be ugly, right? It will be difficult to find the surface area. So the same thing happened here. So from 0 to pi, it's just a straight line, right? And when you rotate, it will not be a problem. Okay, so that's why you need to strict up the some restrictions here. Okay, now if we draw uh, maybe just like that. Okay, and imagine if this is polar, if this is polar axis. Again, it's not xy, it's a polar now. And if we rotate from this curve, rotate about the polar axis. So this is the polar axis is here, the baseline. So we rotate here. And if we are restricted from 0 to pi, then we can see the form, right? Or maybe let me make it like that. Okay. So to find the surface area, let me write general form in parametric. It's usually S from A to B. I just write 2 pi y. Okay, we get this form. And to generate the area of surface in polar, okay, we need to convert the and we know that from previous arc length, so this is the arc length, we can change to r squared plus dr over d theta squared, right? So let's do that. Let's write the new surface area. 2 pi r sine theta and then r squared plus, okay, and that's the um, our surface area in polar. Okay, surface area in polar. And remember the restrictions. Okay, the restrictions. Now the example for the surface is you have r squared cos 2 theta rotated about polar axis. Find this surface area. And the other example, another example, this is the outline. I think find the length of curve. R is equal theta squared from 0 to 5. Okay, so the first one is example for the surface area. The second one is the finding the arc line. They are different questions. Let me give you some time for solving these two problems. Maybe 5 to 10 minutes, and then I will give you the solution and we can finish the class. Hmm. Hmm? Ini kamu udah nyari-nyari? Nggak tahu. Ini apa nih? Oh, P di sini. Nol lah itu. Okay, so for the surface area, what you need to do first is to draw the graph. This is we call the Lemniscape. Okay, we only have two kind of Lemniscape: cos 2 theta and sine 2 theta. Okay, the difference is the cos will be like this. Yeah, more or less like this. And the sine 2 theta will be like that. Okay. So imagine cos and sine is actually just uh, moving the first baseline, because the cos theta is 1 and sine theta is 0. So that's why you need to shift the graph. Okay. Now we need to think what is happening here. Okay. Like let me write this is r squared equal cos theta. Okay. Now from here, this is 0, right? Cos 2 theta. So this is theta is 0. And what is this theta? Yeah, p over 4. Okay. Now we can um, write the equations here, because in surface area we need to find the arc length, right? First, dr over d theta plus r, right? So we need to find the first is the r is just this, right? But to find it, we need to derive so the 2r dr over d theta equal minus 2 sine 2 theta. And dr over d theta is minus 2 minus sine 2 theta over r. R is cos 2 theta. Oh, squared, sorry. Or if you want, we can directly square this. And we get sine squared 2 theta and then cos 2 theta. Now we get S is from 0 to pi over 4. It's actually this to this plus this to this. But it's symmetry, so I'm just using from 0 to pi over 4 and then multiply by 2. Okay, because I have to, right? So let's multiply by 2. Okay. And then 2 pi. My r is cos 2 theta. And then sine theta. And then square root of the r squared is cos 2 theta plus the sine squared 2 theta over cos 2 theta and then d theta. And then simplify this. So this is cos 2 theta. This is 1 cos squared 2 theta, right? Plus sine squared 2 theta. This is the top one equaling 1, right? And the bottom one is just square root of cos 2 theta, which is you can cancel. So it's just integration of sine theta, right? Okay. So 4 pi multiplied by negative cos theta from 0 to pi over 4. So this is the answer. Okay, any question? Basically, what you need to do is just first finding the angle, which angle you need to observe. Okay? And then um, use the formula, find the r squared plus dr over d theta squared, basically the arc length, and then just simplify, and you get all the answers. Okay. Okay. The next question is actually not too complicated. You have the r equal theta squared. Okay. Basically, you can just write the arc length, and then from 0 to 2 pi, and then you can write down the formula, and then d theta. And we can substitute all with our functions. It's actually easier than previous. And dr over d theta is 2 theta squared d theta. Okay, now we have Okay. Now we have this equations. Anyone still remember how to solve this kind of integrations? Yeah, just substitution. Okay, just substitution. So let's just substitution all this theta squared plus 4. Let's say u, and then we get 2 theta d theta, and then du. So d theta is 1 over 2 theta du, and then we can substitute d theta, and then we get half squared of u du, and then this will be changed, right? So when theta is 0, u is 4. When theta is 2 pi, 2 pi squared, 2 pi squared plus 4. So this will be half, and then 2 over 3 u and the rest you can just plug in the evaluations 4 to 5, 4 pi squared plus 4 to here, and then that's the answer. Okay, I think that's it for today. So remember, next week we'll be having a quiz, either Monday or Wednesday. I will let you know later.